Alrighty, Holderback is back again with another video. This one is about, it's for the delta math exercise that's labeled exact trig values graphically for sine, cosine, and tangent. So we're kind of been building little by little, and we're going to keep building. We're kind of halfway to the end of this concept. So what you're going to be given here is some sort of trig function and one of the angles on the unit circle, and you got to find the exact value. So some of them will be easy. Like this one, we already did something like this. Cosine of 45. 45 degrees is in the first quadrant. We already practiced this. Okay. So this one, is pretty straightforward. And what you have to do on delta math is you first have to take the green dot and drag it to a 45-degree angle, and you'll see how to do that. That's not the difficult part. So you do that. I got that here. There's what you would get. And so it basically draws the angle for you. And so cosine, two ways you can think of this one, right? You can think of it in terms of SOHCAHTOA. That's one way. The other way is to remember that we have a coordinate here. It's x comma y, and the cosine of theta of any angle is the x coordinate in the unit circle. So you could think about finding the x coordinate, or you could think about cosine is adjacent over hypotenuse, right? And think about the side lengths of the triangle. Or you might just memorize what cosine of 45 is. It's up to you. But we did spend time on this. A 45-degree angle, the side lengths are 1 square root of 2 over 2 and square root of 2 over 2. This is the one where it's the same. And so the coordinates of this point, if we were going to draw them, I'm going to actually do this because we're going to start using the coordinates here. Again, how far over do we go in the x direction? We go over square root of 2 over 2. How far up do we go up in the y direction? Also square root of 2 over 2. So the coordinates of this point on this xy plane is square root of 2 comma square root of 2 over 2. Sorry, square root of 2 over 2 comma square root of 2 over 2. And so the answer to this one is just cosine of 45. Cosine is the x coordinate. It's square root of 2 over 2. That's it. That's all you got to do. Again, that's something we've done, and hopefully that makes sense. All right. The other way to think about it would be, it's the adjacent side of this angle. The adjacent side is square root of 2 over 2 divided by the hypotenuse, which is 1, and you get your angle out. And so that would be our answer for the first one. So let's look at one that's new now. And what's going to be different is the angle is now greater than 90 degrees. So it's not going to fall within this first quadrant. So 150 degrees, you want to think about where that is on the unit circle, right? 180 this is 180, right? This is 90. Break this up into 30-degree angles. So 30 past 90 to 120, 30 more would be 150. So it's going to be somewhere over there. And so you would drag this to that spot, and when you do, you get that angle right there. So I'm going to erase this. Okay, I'm going to use the bigger marker, I think. And so this angle is 150 degrees. But you can't draw the right triangle with 150 degrees. So this is where knowing the reference angle comes into play. And this is why we were learning this before in the previous videos. So the reference angle for a 150-degree angle is actually it's this angle right here, which is a 30-degree angle. So what we have here, to draw it outside, is actually a 30-degree angle. And we know that angle, right? We know the side lengths of that triangle. We know the hypotenuse is 1 for a 30-degree, a 30, 60, 90 triangle with a hypotenuse of 1. The shorter side is a half, and the longer side is square root of 3 over 2. Right? So that's something we should know, right? And so since we're trying to find sine, right, two ways you can think of it. You could think of sine as so, opposite over hypotenuse, so a half over 1, right? Or the other way is that sine of theta is equal to the y coordinate. So let's do both of these. Yeah, we can do both. So opposite over hypotenuse would just be a half over 1, so it's just a half. The coordinates of this point are the x distance would be that distance, which would be square root of 3 over 2. And the y distance right here is actually 1/2. And now I actually have to go back here really quick. Sorry, and redo the x. So the x, this distance here is square root of 3/2, right? But in terms of the coordinate, because we're now, this is the negative x values over here. This x coordinate is actually negative square root of 3/2. All right, the y is still positive, right? It's still above the x-axis. It's still positive. So the y value is still positive, but the x coordinate is negative. All right, and that's going to be important. Sometimes your answers are going to be positive, some are going to be negative. You want to think about where you are in the quadrant. But for this one, the y value is positive, so your answer is just positive anyway. So the y value would be. Now, if it did ask, it didn't on this one, but let's say it did ask for the cosine of 150. So again, the cosine is equal, cosine of an angle is equal to the x coordinate. And so in this case, the x coordinate is negative square root of 3/2. And so that would be your answer, would be a negative square root of 3/2. All right. So we got to start paying attention to the signs. All right. So again, you start by thinking about what the reference angle is. That gives you an insight to what the side lengths of the triangle are. And then you use either SOHCAHTOA or the x and y coordinate to figure out what the value of the trig function, the sine, the cosine, or the tangent is. And then think about the quadrants. So a lot of different pieces for this one. Let's do another example. All right, sine of 315 degrees. 315 degrees, all right? We got 270s down here, 360s all the way around. So I need to drag this all the way around to, I think it's going to be right there in the middle. So 45 degrees past 270 or 45 degrees back from 360. You do that, there's your angle right there. All right, I'm going to erase this. So what triangle is this? Well, what's the reference angle? This angle right here is a 45-degree angle. All right, hopefully you can see that. All right, it's 45 degrees back to 360. That's its reference angle. So what are the side lengths of a 45-90 triangle with a hypotenuse of 1? Well, it's square root of 2/2. Square root of 2/2. Okay, so sine, and I'm going to start just using the y coordinate as my way of figuring this out, but sine is equal to the y coordinate. So what are the coordinates of this point? Well, the x coordinate is square root of 2/2, and it's positive. The y coordinate is also square root of 2/2, but it's negative because it's down here, right? That's in the negative y values. So the answer to the sine of 315 is the y coordinate of 315, which is negative square root of 2. Okay, let's do another one. All right, we got tangent. Tangent's always a little bit more difficult. 210 degrees, where is that at? All right, that's 30 degrees past 180, right? So there's 180, so 30 degrees past it would be right around there. Let's see if that's right. That's right. Okay, I'm gonna erase that. All right, so this reference angle right here is a 30-degree angle. So the shorter side of a 30, 60, 90 triangle with a hypotenuse of 1, the shorter side is 1/2, and the longer side is square root of 3/2. Okay, what are the coordinates of that point? Well, the x coordinate, if I can actually write here, the x coordinate is how far over you go in the x direction, which is the square root of 3/2. And it's in a negative direction, so it's negative square root of 3/2. And the y coordinate is this part right here, which is 1/2. So it's down 1/2, and again, it's negative because it's in that third quadrant. And so the tangent of theta, if you remember from the previous video, is the y coordinate or the x coordinate. Or you can also think of it as opposite over adjacent, however you want to think about it. So the y coordinate is negative 1/2. The x coordinate is negative square root of 3/2. Right? And you should get your answer there. Now you can also think about it as this is a 30-degree angle, and if you remember what the tangent, the reference angle is 30 degrees. If you remember what the tangent of 30 degrees is, if you remember that it's square root of 3/3, this will save you a little bit of time, right? You can do this math in your head. If you don't, right, you can write it out like this and figure it out on your own. So you have negative 1/2 over this, negative square root of 3/2. You're dividing by a fraction, so you need to multiply by the reciprocal of that fraction. Negative times a negative is a positive. 2's are going to cancel out positives. Negatives are going to turn to positive. You get 1 over the square root of 3, right? remember how to rationalize this denominator, multiply by the square root of 3 over 3, and you end up with the square root of 3 over 3. And it turns out to be positive because you're dividing a negative by a negative. All right. So you end up with square root of 3. That's the tricky one. Let me try to rewrite that one more time. Positive square root of 3. Right? And again, the reason it's positive is because the tangent is the y coordinate divided by the x coordinate. And in this quadrant, in the third quadrant, the y coordinate is negative and the x coordinate is negative. So a negative divided by a negative turns out to be a positive. Okay? If you were to ask to find the sine and the cosine of an angle in the third quadrant, both of those would be negative, right? Because the y coordinate is negative or the x coordinate is negative. All right, let's do another example here. All right, negative 30 degrees, cosine of negative 30. So negative 30 is going to be in a clockwise direction. And if we do that, we'll just go 30 degrees and we'll get right there. Okay. So again, you might just have these memorized, right? Like this reference angle here is 30 degrees. You remember what the cosine of 30 degrees is? You might remember it's square root of 3 over 2. If you've got that, this will save you some time, right? Then the only thing you have to think about is if it's positive or negative. Okay. Right? And cosine is the x coordinate, and the x coordinate in this quadrant is positive. So your answer would be a positive square root of 3. Okay, that's one way to do these, right? Is to find the reference angle. Remember what it is, right? Because you should be good at really fluent at finding sine, cosine, and tangent of the angles 30, 45, and 60, right? And then just figure out what the sine is. That's one way to do this. The other way is to just always draw it. Think about what the coordinates are. Once you know the coordinates, remember if you're finding the x, y, or y over x coordinate. So again, if we were going to find the coordinates, I'm going to just do this really quick. The coordinates of this point, the longer side is square root of 3 over 2. That's your x coordinate. The y coordinate is the shorter side in this case, is how much you go down. So it'd be a half, because you went below the x-axis, it's negative half. Right? And so the cosine is the x coordinate, so that's why your answer is positive square root of 3 over 2. If we wanted to find the sine of negative 30, all right, that would be the y coordinate, which we know is negative. Okay? So that's how you do these. You draw the angle. The angle reveals the reference angle, and that helps you figure out what the value of sine, cosine, or tangent is. All right. If this is struggling for you, remember we have tutoring sessions at 10 a.m. and 1 p.m. every single day. Go to my website, click on the link for that session, and then you can share your screen with me on Delta Math, or I can share my screen with you, and I can walk you through how to do one. All right. Not a lot of people have been taking advantage of that. So if you are struggling with these, they are getting more difficult. That is a good opportunity to get some help or get some clarification on what you're doing. Okay. I will talk to you guys soon.